You walk down the grocery aisle, casually tossing items into your basket. Milk? Check. Cereal? Yes. That frozen pizza you love? Wait, hold on, did you know almost 90% of processed foods like this contain genetically modified ingredients? It's true. From your morning toast to your evening snack, GMOs are woven into the fabric of our modern diet. But are they the villain in a sci-fi movie or a silent hero boosting our food supply? Buckle up, because this isn't a black and white story. We're about to dive into the complex world of GMOs, exploring their potential to fight hunger, their possible risks, and the heated debate swirling around them. So grab a bite, GMO or not, get comfortable, and let's untangle the truth together. Imagine a world where crops resist pests, are fortified with essential nutrients, and can withstand harsh weather conditions. This is not a figment of some science fiction author's imagination, but a real possibility brought to us by the marvel of genetically modified or GMO crops. Harnessing the power of biotechnology, scientists employ transgenic technology and gene splicing to create these wonder crops. By inserting or modifying genes, plants can be endowed with characteristics they wouldn't naturally possess. Think of it as giving them superpowers. These superpowers have the potential to revolutionize agriculture. Increased crop yield is an obvious advantage, but there's more. Imagine reducing the use of pesticides, a major environmental concern, or enhancing the nutritional content of crops, potentially combating nutrient deficiencies in populations around the world. Thus, GMO crops hold the promise of a future where hunger and malnutrition could become relics of the past. However, like Pandora's box, GMO technology comes with its own set of potential risks. One of the significant concerns revolves around the possibility of creating superweeds. These are weeds that can inherit the traits of GMO crops, such as resistance to herbicides through a process known as gene flow or outcrossing. This phenomenon can lead to an increase in the use of chemicals, potentially exacerbating environmental pollution. Additionally, the introduction of genetically modified organisms can disrupt ecosystems by altering the balance of organisms. This is due to the potential for these organisms to outcompete their natural counterparts, leading to a reduction in biodiversity. A related concern is that of genetic contamination, where the genes from GMOs cross into natural organisms, posing long-term risks to the natural gene pool. Another potential risk is the possibility of GMOs causing allergic reactions. Genetic modification often involves the introduction of genes from one species into another. If the transferred gene produces a protein that triggers an allergic response in some individuals, it could result in unexpected allergic reactions. Moreover, GMO technology also raises several ethical concerns. For instance, the monopolization of seeds by large corporations can lead to a loss of control for farmers over their own crops. This could exacerbate economic disparities and threaten food sovereignty, particularly in developing countries. Furthermore, the manipulation of nature through genetic modification opens up a Pandora's box of potential unforeseen consequences. While we may understand the immediate effects of introducing a particular gene, we are still grappling with the complexity of genetic interactions and the long-term implications of these modifications. The potential for unintended effects is an inherent risk in any technology that manipulates complex systems, and GMOs are no exception. Thus, while the benefits of GMOs are alluring, their potential risks necessitate a cautious approach. As we continue to explore this frontier of science, it is crucial that we do so with a deep understanding and respect for the complexity and interconnectedness of nature. Let's delve a little deeper and explore some common GMO food crops and weigh their impact. Herbicide-tolerant soybeans. Increase farmer profits due to reduced weed control costs and potential yield benefits. However, concerns remain about increased reliance on specific herbicides and potential development of resistant weeds. There is no doubt an improvement in livelihood for farmers, especially in developing countries, but debates about corporate control of seeds and potential impact on small farmers remain. Insect-resistant corn, Bt corn, reduces pesticide use, leading to cost savings and potential environmental benefits. However, there are concerns about the development of resistant insects and potential non-target effects on beneficial insects. Again, there is an increase in food production and potentially lower food prices. However, debates about potential harm to biodiversity and farmer dependence on specific technologies are concerns. Golden rice was developed to address vitamin A deficiency in developing countries, with potential economic benefits through improved health and productivity. It also aims to improve public health, particularly for children. However, debates about limited effectiveness, unintended consequences, and potential commercialization concerns have arisen. Non-browning apples, Arctic apple, increased profits for growers and retailers due to reduced food waste, but concerns about consumer acceptance and potential impact on traditional apple varieties have come up. GMO canola, increased oil production, and improved processing characteristics. However, concerns about increased herbicide use and potential negative impacts on bee populations are concerning. While there are potential benefits for the biofuel industry and food production, there are also debates about environmental sustainability and potential harm to non-target organisms. These are just a few examples, and the impacts of GMO crops are complex and vary depending on specific contexts and perspectives. Here are some exciting areas of recent progress in the GMO field. CRISPR-Cas9 technology. This revolutionary tool allows for incredibly precise editing of genes. Researchers are using it to develop crops with improved drought tolerance, enhanced nutritional value, and resistance to specific diseases. Base editing. This new approach allows for modifying single nucleotides within genes without introducing foreign DNA. This holds potential for creating beneficial changes with potentially fewer regulatory hurdles. Golden rice 2. This improved version of golden rice addresses earlier critiques by incorporating multiple genes to increase beta-carotene content while maintaining desirable agronomic traits. Biofortified cassava. Scientists are using gene editing to develop cassava varieties with higher zinc and iron content, addressing critical micronutrient deficiencies in developing countries. Drought-tolerant crops. Researchers are using gene editing to introduce genes from other plants or modify existing genes to improve drought tolerance in crops like maize and wheat. RNA interference, RNAi. This technology can be used to silence genes, essential for pest or pathogen survival, offering a more targeted and potentially safer approach to pest control. Gene editing for disease resistance. Researchers are using gene editing to introduce genes that confer resistance to specific diseases, reducing reliance on chemical pesticides. This list is just a glimpse into the exciting world of GMO research. These developments hold immense potential for improving food security, nutrition, and sustainability in the face of global challenges. Here are some lesser-known facts about GMOs. GMOs aren't new. Humans have been modifying organisms for centuries through selective breeding and grafting. GMOs simply use more precise techniques. GMOs aren't just food. GMOs are used in many products beyond food, like medicines, industrial enzymes, and even biofuels. There are non-GMO GMOs. Some crops undergo mutations naturally or through traditional breeding methods that result in genetic changes, but they're not labeled GMO because they weren't created in a lab. GMOs can help preserve biodiversity. Genetic modification can be used to introduce disease resistance to endangered species, protecting them from threats like invasive pests. GMOs can fight climate change. Some GMO crops are engineered to be more drought-resistant or require less water, which can help reduce agriculture's impact on water resources. Animals can eat GMOs too. Many animal feed ingredients, like soy and corn, are already GMO-derived, and studies haven't found any negative effects on animal health or safety. GMO research is heavily regulated. There are strict regulations governing the development, testing, and approval of GMOs, ensuring their safety and environmental impact are thoroughly assessed. Not all GMOs are the same. Different GMOs have different modifications and purposes, so generalizations about their risks or benefits should be avoided. GMO research can benefit organic farming. GMO techniques can be used to develop disease-resistant organic crops, reducing reliance on pesticides and improving organic yields. The future of GMOs holds immense potential beyond the advantages we see today. Imagine crops engineered to synthesize essential vitamins not currently found in them, combating malnutrition on a global scale. Picture plants with built-in resistance to a spectrum of emerging diseases, ensuring food security in the face of changing climates and pathogens. We might even see crops designed to capture excess atmospheric carbon, contributing to environmental solutions. Advanced gene editing could allow for designer crops customized to specific nutritional needs or growing conditions, optimizing both yield and health benefits. Furthermore, GMOs could revolutionize biomanufacturing, producing novel materials, medicines, and fuels in a sustainable manner. While ethical considerations and rigorous testing remain paramount, The future of GMOs holds the potential to transform agriculture, healthcare, and even our approach to environmental challenges, creating a more secure and sustainable world for generations to come. The question, then, is not whether GMOs are good or bad, but how we can balance the potential benefits and risks. As we navigate the labyrinth of genetically modified organisms, it becomes evident that the key to this puzzle lies in striking a balance, a delicate harmony between the bountiful benefits and potential perils. This equilibrium hinges on rigorous testing and regulation of GMOs to ensure their safety. The stage for this testing is not confined to the sterile white walls of a laboratory. It extends to the verdant expanses of our farms, the hushed corridors of government bodies, and the bustling hubbub of public forums. Each of these arenas plays a pivotal role in this intricate dance of risk and reward. Biosafety, a term that encapsulates the safe handling, use, and transfer of GMOs, is the linchpin of this process. It sets the standards that guide the development and application of GMOs, ensuring that their potential does not morph into a Pandora's box of unforeseen complications. Risk assessment, a meticulous process of evaluating the potential hazards and determining the magnitude of their impact, is another crucial cog in this machinery. It puts the pros and cons of GMOs on a scientific scale, measuring with precision the weight of each. Public consultation, the voice of the people, is the compass that guides this journey. It brings to the table diverse perspectives, ensuring that the path we tread is not just scientifically sound, but also socially acceptable. Transparency in this context is not just a virtue, but a necessity. It is the bridge that connects the world of science with the public sphere, fostering understanding and trust. Public education then becomes an essential tool in demystifying GMO technology, dispelling fears and sparking informed discourse. With these elements in place, we can navigate the enigma of GMOs, not with trepidation, but with confidence and curiosity. We can embrace the potential of this technology while keeping a vigilant eye on possible risks. With a balanced approach, we can harness the power of GMOs for the greater good, while minimizing potential risks. So, are GMOs friend or foe? Share your thoughts in the comments and let's keep the conversation bubbling. And don't forget to subscribe for more science adventures.